Digital imaging basics. The digital camera's job, unlike the old film cameras where I had to take the pictures and then take the film back and process it and print it to see what my final images look like, now the digital camera allows you to see the image immediately and frame up what you want, make sure that the picture is focused and that it is properly exposed. Saves a lot of time and money and trouble. This is a great leap from the good old days of film photography when it took me 30 minutes at the bare minimum to develop, process, and print an image and be able to see what I'd captured. Here are some examples of cameras, digital cameras. This is a digital single lens reflex camera, a couple of different views. Here are exploded views of a digital camera, showing you how they are made, how the light comes through the lens, strikes the mirror, which then reflects the image up to the ground glass. You look through the eyepiece and a pentaprism. The image is right side up and correct left to right. When you push down on the shutter release, the mirror comes up out of the way. The light continues past and hits the recording material, CCD, at the back of the camera. Here's an illustration of the same thing. With the digital single lens reflex camera, the light comes in, strikes the mirror, the image out in front of the camera, you focus on the image. You point the camera at the image that you want to capture and focus the lens. The image comes through, strikes the mirror, and the image is reflected up to a piece of ground glass. You have your eye up to the eyepiece, and you can see what you're going to capture. When you push down on the shutter release, the mirror comes up out of the way, and the light continues through down to the CCD to capture the image. With the electronic viewfinder, the light comes through, strikes the digital media, and is displayed up on the eyepiece so you can see what you're capturing an image of. And or you have a camera that doesn't have an eyepiece, and it just displays the image on the viewfinder on the back. The difference between a mirror and a mirrorless camera. The mirrorless cameras are substantially smaller than the digital single lens reflex cameras. The light comes through, strikes the CCD, and the image is displayed either on the viewfinder on the back or through the eyepiece on top of the camera. On the digital single lens reflex camera, the light comes through, strikes a mirror, the image is reflected up onto a piece of ground glass. You look through the pentaprism and you see what you're going to capture an image of. You push down on the shutter release, the mirror comes out of the way, and the light continues to the light-sensitive material, and you capture your image on the CCD or CMOS chip. Camera lenses are designed and built to allow you to minimize the distortions, the aberrations in a lens. The light comes through the lens and is redirected, refracted, and then is captured on the CCD CMOS chip at the end of the lens. Here's a tour of the back of a digital single lens reflex camera. You have a lot of choices to make. I'm not going to point out all the different things in here, but you need to learn and read your camera manual so that you know what all these buttons do and how to make good use of them. Here is the display on the back of the camera showing you how you're going to capture this image, what your shutter speed is, your f-stop, your ISO, what the camera is set at. Here are the different shooting modes with both Nikon and Canon cameras so that you can choose and you can tell the camera what you're going to take pictures of, and so that it'll help you do the job that you want. So if you're doing landscapes, it gets you a very small aperture and a lot of depth of field. If you're going to do pictures of a sporting event or something like that, and you want to stop the action, have a choice here where you can choose the shooting mode to accomplish that goal. We assume that our camera sees and captures what we see. That is not always true. On a bright sunny day in an outside situation, it works quite well. But if you take your camera out of that situation into a interior lit by artificial light situation, then you need to adjust the camera and the options available to allow you to capture the image that you're seeing on the display in your camera. The camera does not always automatically do that. You need to make a test exposure and make the necessary corrections so that you make the proper exposure and actually capture with your digital camera what you're seeing. It is not a given. White balancing. Your eyes adjust to the environment that you're in. The camera does not do that. Again, this is one of those situations where you need to make good decisions and use the available options on your camera. You need to make a test exposure with the digital camera and look at what the camera is going to capture. And then you need to use the available options so that you can capture what you are seeing and make sure that the camera is capturing what you are seeing. Here are some illustrations of blended light situations or situations where we have different lighting environments. Up in the upper left, you've got twilight and incandescent light. So you've got two different lighting environments. So you can choose one or the other, but you cannot get both. The lower left is you're using a digital camera. You're taking pictures of an incandescent light and we're using a daylight exposure. And so the camera is capturing what it sees, but you need to tell it that this is an incandescent environment because your eyes see this as normal light, but the camera captures what it sees, which is this orange environment. Up in the upper right is multiple different lighting situations. You've got cloudy, you've got incandescent, automatic white balance, and custom. So these are examples showing how the photographer here has adjusted their exposure to properly document and the lighting situation. In the lower right, you've got the interior of a house that's lit with maybe incandescent or maybe LED, and you have white balanced this so that it looks, you've captured an image like your eyes see it so that you can get this image. But you'll notice that the windows on the right side are outside, and the view out there is blue. When you look out there, you see this as normal daylight. What do you do when the lighting situation changes, or you find yourself in a situation where the lighting is not a bright sunny day? You've got to look at your available options and try the auto white balance. And if that's not good enough, you have to assess the conditions, the quantity, quality, and Kelvin temperature of your environment that you're capturing your images in. Make a test exposure and look on the back of your camera and to see what the camera is capturing. You might choose to go with one of your preset options that is available that you can use for like incandescent, where the camera has limited range where it can make corrections within that type of lighting environment. Review the image and adjust it as necessary so that you're capturing the image that you are seeing with your camera. I like this option. This is a wonderful option. When you go out and you're in a consistent lighting environment, you make an exposure, adjust the white balance that you're going to capture the image that document this scene. Then you can go ahead and keep shooting until you finish taking all the pictures in this environment. This is a wonderful option. And when auto white balance doesn't work, then you need to look at the available options that are on the dial of the key. What do you do when lighting conditions change? If auto white balance doesn't produce the exposure that you want, then you need to make adjustments to make sure that the camera captures what you're seeing. As a photographer, you need to have more than one memory card with you when you're out taking pictures. And you need to carry additional batteries because your camera is not even a good doorstop. It makes a good paperweight, but without a battery, it doesn't work. Back in the good old days when I was taking pictures, you could always go to the local, what we called Stop and Rob, which was a convenience store, and you could buy AA batteries and move on. Well, now all the batteries in these cameras are all proprietary, and you need to buy them from the manufacturer. And if you don't have a charged battery to put in your camera, again, it's a good paperweight, but that's about all it is without a good battery. Digital image sensors. These discs are manufactured in a very secure environment with special conditions. One of my students in the past worked for Intel, and I asked him about how these are manufactured and how close someone can come to the actual area where these are being produced. And he said, no one has been in beyond 3 levels out since the factory was manufactured. That it's all automated and run by machines so that they can keep down the dust and dirt in there so that they can produce the highest quality chips. They produce these wafers, discs about this big, into small chips, and you put them in your cell phone because you don't need a big sensor in there. They don't use those. But when you've got something like a digital single lens reflex camera and you've got a big sensor, then they need to be careful and make sure that there aren't any problems in the disc in each of the sections, and they get fewer out of a disc, so they are much more costly as they get bigger. Here are some examples of the sizes of these sensors. You can see where it's a full frame 35 millimeter, that's 24 by 36 millimeters. And there down at the lower right, you get one that's 4 millimeters by 3 millimeters, about 5 by 3.5 millimeters, significantly larger. So you get a lot more 3 by 5 chips than you get by 1 by 1.5, the full frame 35. They are very expensive to manufacture. Again, this is the inside of your typical point and shoot digital camera. There are no springs and gears. They're gone. You have to be very careful. You don't want to be dropping this camera and have it fall on the wrong edge because it'll spider web. It'll crack all of the circuit board there, and there is no fix to one of these. And even if you bought this camera 6 months ago, don't even think about taking it into a camera store and ask if they can repair it. It's not worth fixing. You take the memory card and you take the battery out of this camera and you drop it in the trash and you go buy a new camera. This is a 35 millimeter film frame. There are some cameras that capture full frame digital images. There are a few of them. Again, these chips are very expensive. The outline of the green is a 1.3x Canon camera frame. That's what they would capture of this scene. The red rectangle is for a Nikon DX. That's a smaller area of the same thing when you're from the same distance pointing this camera at that scene. The blue rectangle is the Canon. It goes 1.6. That's 1.6 times the focal length of your lens in the image that you capture. Nikon FX and the Canon full frame are the same size as the film image. This is how a digital image is captured. You have these little light cavities. This is a little place where you actually capture your images. You have red, green, and blue little cavities. There's a filter over each of these. Only the red come through the red filter, only green comes through green, and only blue through the blue. Or there's one that comes through with blue and green. Each of these are captured, and then the images, these different little cavities come together, and they produce a full color image. This process uses what's called a Bayer filter pattern. The red, green, and blue produce all the colors of the rainbow using red, blue, and green transmitted light. Here's an example of how this works. The light comes through the lens, strikes this Bayer filter. The information is sent to an image processor and then is displayed on the back of the camera and or saved on a CCD CMOS chip. Here, optical versus digital zoom. The original image on the left is the full frame picture of the bunny. The image of the eye is 10x optical. That means that you have a lens that has 10 times the magnification, a telephoto lens, that you can full frame capture a picture of the bunny's eye in the lens onto the digital image material. The one on the right you can see is the bunny's eye, and you have increased the size button on your computer, and you can increase the size of the eye of the little bunny up to this size. You can start seeing the pixels, the little rectangular squares in this one, but they use the digital image to increase the size of this image, of this eye. Bit depth illustrates the different values that you can use for it when you're capturing an image. A 1-bit image is either black or white. And then 4 bits, you've got 4 shades of gray, from the whitest white to the blackest black here, and you can use the 4 colors to make this image. 8 bits is 8 shades of gray, from the whitest white to the blackest black, so that you can create this image so you get a more realistic documentation of this image. Here, when you get into color, the human eye can only discern about 10 million different colors. But we have 24-bit, we have 8 bits of each of the red, green, and blue colors. When they overlap, they can create all the colors of the rainbow. So you have 8 reds, lightest red to the darkest red, 8 of the greens from the lightest green to the darkest green, and 8 blues from the lightest blue to the darkest blue. And then you can work them together in combinations. You can see the illustrations on the right where they use the different bit depths to produce uniform and the variety of colors, like I say, the same colors that you can see in the rainbow. Here are more illustrations showing 8-bit versus 16-bit images. The one on the right is Mario. You've got 8-bit versus 16-bit, showing you how you can get more definition and better graduations. Here, exposure value compensation. Most cameras have an exposure value or control. This allows for manual correction of the exposure so that you can capture what is most important in the lighting situation. If the most important thing in this image is the sky illustrated here, then you need to go to -2 so you get a dark sky, so you can see the blue sky and the clouds, and you sacrifice everything in the foreground. Or off to the far right, you see +2. Here, the road in front of this building is the most important element of this image, and so you are overexposing everything else so that you can get a good picture of the road. Here's other situations. Here you've got the snowman up on the top level. If you want detail in the snow, then you need to go -2 to get detail in the snow. But you don't get the nice soft detail. And then you go +2 when you want to go have a snowman looking white. The picture on the bottom shows an indoor pool in a covered environment. If you want to see what's outside the windows of the pool, then you need to go to -2 and you sacrifice the pool in the foreground. And if you want to show the pool as shown in the right, then you go to plus, and the outside is overexposed. The most common situation I would find myself in using this is in a burned out building, and I would start at +4 at a burned out house and make a couple exposures, see if that was enough overexposure so I can capture the detail in the burned area. And then I would go from there and I make the adjustments so that I could capture all of my images using that type of exposure to get the detail that was required. What is digital noise? Digital noise is produced when you use a high ISO that allows you to capture images in a low light level. You send more electricity through the CCD that you're capturing your image on, and that makes it more sensitive so that you can get images in these low light level situations. Here's an illustration showing the difference between ISO 100 and ISO 3200. The pixels are not even visible in the 100 ISO. They are just marginally visible in the 800 ISO. They start really showing up in 1600 ISO, and in 3200 ISO you can see like there's little sand or gravel. Those are the pixels that are making up this image that have to be excited to allow the photographer to capture this image at this high of ISO. Image capture formats. You can capture your images raw. These are uncompressed data, the light that comes through the lens and strikes the CMOS CCD at the back of the camera, unaltered at all. Then there's what's called TIFF, is a minimally processed file format used for storing images. And then there is JPEG, Joint Photographic Experts Group format. It is the most commonly used compression format for storing images. It works, it's good, but every time you open and save a JPEG image, the format tries to make the image better, and it alters it each and every time you open it and resave it. So it's not a good choice all the time. Metadata is a digital catalog system. Metadata describes how and when and by whom the data was collected. Every time you save a digital image or document or music or any type of computer-generated file, there is metadata. And this metadata can be discovered and be used in a courtroom situation. Examples of data collected: file name, capture date and time, camera make and model, exposure, shutter speed, f-stop, and sensitivity, ISO. And if your camera has GPS capability, it will actually capture where you are capturing the image. It will save that data as a part of the file. This is an example of the metadata that is captured within the image. You can go in and find out about the image. You need to be careful when you're capturing images and you want to save as many images as possible in a very small space. When I capture my images, I always capture them in a very large file format, about 20 megapixels per image. That's huge. But that means that it takes up a lot of space on my SD card, in my camera, and in my storage in my computer. If all you're doing is taking pictures to put something up on eBay, you don't need a 20 megapixel image. And pictures going through your phone and for local use can be very small. And if you're going to be making pictures, prints, you need a couple megapixels to be able to make a 8x10 print. And you have to understand that if you're going to crop one of your digital images, you're cutting down on the number of pixels that are being saved. And so you need to have a pretty good sized image to allow you to make the adjustments that you want to make and produce a high quality image. Resolution, the amount of detail captured in an image. It's measured in megapixels. More pixels mean more detail. The number of pixels is not the only factor in determining the image quality. Here, when you only have one pixel, one dot to illustrate, document what you're taking a picture of, you get this one square, and it's just one uniform colored square. If you've got four squares, 2 by 2, then you get 4 different little squares. But it still doesn't give you. And then you get 5 by 5, and now you've got 25, and you still can't see, but it's getting better. And then you get 100 rectangles, and you start seeing more and more about what you're capturing an image of. And then you get 20 by 20, 400. You can see what you're looking at, but it's got a sawtooth edge. And then you've got 50 by 50, which is 2,500. And so it's kind of blurry, but the edges are not nice and soft and or hard, so you can see the detail that you want. And then 100 by 100 is 10,000 pixels. And so now it's much better, and you get a much better idea of what you're capturing images of. Here's an illustration showing how pixels work in an image. The one on the lower right is probably, 10 by 10, 100 pixels, and you can't see much of anything. To the lower left is probably 25 by 25, and you see the sawtooth edge. It's starting to get good. And then you upper right, you see the 100 by 100, and you got this ragged edge that doesn't do a really good job of describing what you're taking a picture of. And then you get to up into the megapixels, millions of pixels, and now you get a top quality image. You need to be very careful about what the words that you choose to describe an image in court. Manipulation is not a term that we use in court. It denotes that something has been altered or changed. We use the words enhanced or processed. That's what we do to images. We might crop them. We try to stay away from that. We try to stick with enhance or process to make the picture more understandable to the judge and the jury. Advantages of digital consumer cameras. Instant review of the images. You can see what you're taking a picture of, and if you don't like what you've taken a picture of, you can take another one. You only pay for the prints you want. You can capture all the images you want up to the limits of your storage in your camera. And your images that you capture with a digital camera are second generation originals. They are real. Nothing has changed from one to the other. They are all the same image. Why does it take my digital camera so long to capture an image? Well, it can take the camera up to 1.5 seconds to power up and determine the proper exposure when you decide you need to take a picture. And if the camera decides that you need a flash, that takes additional time. So there is this delay, and you're standing there in this image that you want to capture is happening before your eyes, and you push down on the shutter release, and nothing happens. Well, this is what happens. The camera takes up to 1.5 seconds to power up and determine the correct exposure, and to establish whether or not you need to use a flash to get the image that it thinks you need. And that's the end of this chapter. If you have any questions, please feel free to contact me.